Hello, this is John Clark. I'm going to go through assignment 1001, Battle for Crymland. I'll start off by quickly going through the parameter file. What I found is that with the default values, Mr. Big was consistently getting arrested within 10 weeks. I changed solve init to be 0.01 and solve cap to be 0.1. He still gets arrested quickly many times, but other times it goes a bit longer than that. What I found also was in many cases crime would spiral out of control, so I added a parameter called stop simulation, which represents the number of thieves. In this case, if we hit 50,000, the program exits. So I'm going to go ahead and execute the code, and we'll see what happens. You can see in the last run, it went 64 weeks, and the town was overrun with criminals. So I'll try it one more time. Okay, in this case it only took 8 weeks. I'll try it one or two more times. Okay, here we're going quite a bit longer. Okay, now we're overrun by criminals. Okay, so now I'm going to go ahead and talk through the code. First, with regards to how I dealt with the input parameters, I used a class to read them into a dictionary, which I call parms, and I passed that entire parm list to the functions that needed one or more of them. And the way that I basically structured this is with some global tables. So just to look at the thieves table, it includes net worth, type of thief, whether it was lieutenant, Mr. Big, standard thief, who the boss was, a flag as to whether the thief is being investigated, whether they've been put in jail. If it's a lieutenant or Mr. Big, I record the number of thieves working for them that have been arrested. I also track recent week earnings for people at each level in the hierarchy. I needed to be able to access entries in that table directly to update the cut that's distributed to the hierarchy of lieutenants up through Mr. Big. And to do that, I created a global dictionary. For the detectives, I also had a global table that stored the success rate, the last bribe attempt, the amount that they seized through arrests, whether the detective had been bribed, the likelihood of being caught if bribed, and a flag if they are indeed caught being bribed. Process week was a core function that drives much of what the program does. It calls 8 different functions and methods to conduct the heist, update the cut, distributed to bosses, assign cases to investigate cases, check to see if there are enough corroborators to arrest a boss, attempt to bribe detectives, and then go through a cycle to detect corrupt detectives. There's also a weekly stats function, which I'm not even going to try to find here, which simply prints results for the week and then writes them to a file. I'll mention a couple other things. There was a question on how to distribute the cut from the heist to the thieves through the network of lieutenants up to Mr. Big. For that, I ended up using recursion with a base case of hitting Mr. Big, at which point the distribution would stop. There are 3 classes, which I've got towards the bottom here. I had a class for a thief, which included some behaviors related to a heist. I had a class for detective, which included behaviors related to investigations, and then, as I said, I had the class for the input parameters, and then I reused the 6, 10 and 20-sided die classes developed in the previous assignment. So that's it. End of video.